So today we're going to talk about a normal distribution or a normal curve. It's a special type of distribution which some people also call a bell curve. We will not. We'll call it a normal distribution or a Gaussian function. You'll also hear it called a Gaussian function because it's named after the mathematician Gauss. This is continuous. A continuous distribution is one that has no breaks in it. The mean is mu, and the standard deviation is sigma. Okay. It's symmetrical, which means the mean and the median are equal. All symmetric distributions, the mean and median are equal because the mean is not pulled by the tail, because there is no tail, or the tails are the same on both sides, really. So let's look at some other properties of the normal. All normal distributions are bell-shaped, but not all bell-shaped curves are normal. On the AP exam, it's important that just because you see a curve that you think is normal, you don't say it's normal unless they tell you. Also, on any exams in my class, same way. If you just start saying things are normal when in fact they're not, you will be marked off. And here's my example. All dogs are mammals, but not all mammals are dogs. In other words, a normal distribution is a type of bell curve. Another thing, let's talk about inflection points. For those of you who had not had calculus, an inflection point is where a graph turns. And the inflection point occurs here at the first standard deviation. And that's both on the left and right hand side of the graph. This is just one of the properties of a normal distribution, which they may or may not ask you on either a unit test, a test in the future, or the AP exam. It's important you know this. Next, let's take a look at the empirical rule. It's the empirical rule, or the 68, 95, 99.7 rule. And what this says is it says about 68% of all data is within one standard deviation. So that's the center plus or minus one standard deviation contains 68% of the data. 95% of the data, this is 13.3 plus 34, that gives me 47.5. 47.5 plus 47.5 is 95. And I want you to look at something. Well, first of all, let me show this. These are the inflection points. Secondly, look at three standard deviations and think about and ask yourself, what does that mean? Almost all the data, 99.7%, that's almost all, of the data is the mean plus or minus 3 standard deviations. That means for something to be 4 or 5 standard deviations from the mean in a normal distribution is a pretty rare event. So it's important we know that, especially as this class progresses. So I'm going to pause for a second, just so that you can pause the video and write down this curve and label the inflection points and everything else, because this is going to be important, certainly for the AP exam, as well as for my class. Okay, here's a quick example using a normal distribution and the empirical rule. Real quickly, I'm going to show you how you'd write some things out of here and how you'd take some information out of here. First thing I want you to notice is it says the average length is 500 hours. The standard deviation is 24. And it's normally distributed. You can write it like this: normal, mean, and standard deviation. In this case, it's normal. The mean is 500 because that's the average. And the standard deviation is 24. So I'll give you a second to look this over, because I think it spells it out pretty clearly how to use the empirical rule. And again, you can pause this and take notes, which I recommend. And if you have any questions, please ask me in class, please. And then here's another example that we'll walk through, and we'll actually use the empirical rule ourselves. So let's read the question. It says, many states have programs for assessing the skills of students in various grades. The Indiana statewide testing for educational progress, I'll call it ISTEP, or ISTEP, is one such program. The mean is 572. The standard deviation is 51. Assuming these scores are approximately normally distributed, and they give you what it would look like if you write it out, use a 68, 95, 99.7 rule to give a range of scores that include 95% of these students. Okay, since it's 95%, we know that it's going to be the mean plus or minus 2 standard deviations. So one of the things I like to do is I like to have a little shopping list over here. And I like to label things so I know what they are. My mean is 572. Oops. 572. Also, just so you notice, I'll bar all of my 7s. The standard deviation is 51. So I go over here, I say, okay, mean is 572 plus or minus 2 times my sigma, and my sigma is 51. That means I have 572 plus or minus 2 times 51, I'm pretty sure is 102. Do a little bit of mathy stuff over here. 572 plus 102 is 674. I'm going to put a comma here. And then 572 minus 102 is 470. I'm going to put these in parentheses like this, just so I know this is a range. But you know what I'm thinking? I'm thinking, this is a statistics class. This is not a math class. In a statistics class, we want to make things a little more clear. So I'm going to put this into context. So I'll give you a second to write everything down. And then I'm going to write this in context. In other words, I'm going to put this back into the problem so that I can explain to somebody who knows nothing about statistics. So I'll pause for a second, and then I'll show you the answer. So here it is, written out in context. We expect 95% of the scores for the ISTEP to be between 470 and 647. Whoa, 674. Let's fix that right now, shall we? And 674. So I want you to notice a couple things. First of all, I put everything back into context. I said the scores for the ISTEP are going to be between these two values. And I didn't say we know for a fact. I said we expect. We expect. That gives me a little bit of wiggle room. That way, let's say we find out it's actually 471 to 674 or 472. We say, hey, we expect this, or only 96% of the data, or something. So we're going to give ourselves a little bit of wiggle room in statistics. And if you wanted to, it might even be safer to say to be between about 470 and 674. That's if you want to. You don't have to include the about. I can take you either way. Okay, this concludes our lesson on section 2.2 for the normal distribution and using the empirical rule. If you have questions, you better ask. Good luck.